When you've got an expression with two terms and that whole expression is squared, you're effectively multiplying it by itself. So if you want to, you can write it out like this. Now in this example, I've got x plus 2 squared. So if I write it like this, perhaps it's easier then to see what's going to happen. Using your FOIL method, firsts times the firsts, we get x squared, and then our outsides, our insides, and our lasts, we can expand it to make 4 terms. Gathering up the outside and inside terms, we get what we call here the middle term. Now, to look at this in a more general way, let's say if we have x plus anything at all, then we can see that there's going to be a pattern with what we get each time. We're always going to get the first thing squared as our first term, and we're going to get the last thing squared as our last term. But what we get in the middle, because the insides and the outsides are effectively the first term multiplied by the second term, and we have 2 of them, we can multiply these terms together and then double it. So we get ourselves a little bit of a shortcut like this. Now, if we have an expression that looks just like this and it's in this form, we can always rearrange it as a perfect square. But what if it looks a little bit like this, but it's not perfect? Well, the part that often spoils the party and isn't perfect is this last term. And that's okay because it's the part that's the easiest to make up for. Let me give you an example. If we have the first 2 terms being like this, and we're trying to factorize it and turn it into something that looks like that, the pattern says that whatever goes here, if we double it, that's what the coefficient of x will be. So it makes sense that if we look at the coefficient of x and just halve it, we can really quickly and easily figure out what this number needs to be. And in this case, it would need to be a 4, right? So for this expression here that has an x squared and an 8x in it, to be a perfect square, the thing that we need to come along at the end would be this last thing squared. We need a 16. Okay. Now, what if it isn't a 16? What can we do about it? Well, we can make up for it. So let's just say we're trying to make a perfect square and we have something like 15, and we think, oh, it's going to need to look like this because these 2 terms sort of govern what we're going for here. The 15's wrong. It really needs to be a 16. We can say, all right, well, what if it was a 16? Let's just add 1 to it. Then wouldn't it be right? Oh, but I've changed the question. We could take that 1 off again. Okay, what I've done here is I've taken the question and I have just altered the look of it a little bit. I've added 1, but then I've taken it off again. So it's actually equivalent to what it was. But what I have done is I've allowed myself to say, now I've got 16, and I can work with that. That all simplifies down to this. And all I'm left over with, as a sort of correction factor, if you like, is the -1. That is essentially the process of completing the square. Take the first 2 terms, the squared term and the other term in x, figure out how they need to go together to make this arrangement, and then figure out what leftovers you need to make up for that 3rd term perhaps not being quite right. Now, in the last example, the number that was at the end was a little bit too small. Other times it will be a little bit too big. Now, in this one, I can see that what I'm going for here is x plus 3 all squared, and I can figure that out because I've just halved the 6 to get the 3. Now, looking at this, it would expand out to x squared plus 6x plus 9. I don't have 9, I've got 10. All right, same idea. If I take 1 off the 10, now it's 9. Oh, but I've changed the question. Let's add 1 back on. Now I can see that here, effectively, I've got x squared plus 6x plus 9, and that's what I have here. And I need to tack on a 1 on the end. Now, a method that I like to use is actually leaving a line and going down to the next line and saying, look, I'm after something that has this sort of shape to it. X plus or minus something all squared. And I can tell it because there's no coefficient in front of the x squared here that I'm going to be able to get that arrangement. Now this -8 tells me that I'm going to need -4 here. Okay, so that's helpful. This is what I'm going for. And the x squared and the -8x can work together to build this sort of scenario. The -1 may or may not be the right number that we need. I can see that it's not the right number that we need. But now my strategy is to expand this out and see what I would get. Now, automatically I'm going to get the x squared and the -8x, so that's good. But when I expand this out, my last term will be -4 times -4, which is plus 16. Now, the second line and the third line are equivalent, aren't they? But this is not what I've been given, so I need to somehow adjust for it. Now, there's a few ways you can do this. You can say, hey, this is different from my question. I've added 16. So how about I just subtract 16 again, and it's almost like the plus 16 and the minus 16 were never there because they add up to 0. Now I need to put in the number that was in my question. Now when I compare these two, I can see that they're exactly the same. There's a 16, but I've taken it away again, so it's all good. But when I compare these two lines, I can see that these three terms are taken care of here, and these last two terms are my leftovers. And I can add up what I've got there. Minus 16 minus 1 is minus 17. And I'm done. Practicing another one now that's a little bit trickier. I'm going to again leave a line and say I'm looking for something that has this sort of shape to it. What needs to go there? Well, I need to halve my minus 7. And the easiest way to do that is just write minus 7 over 2. Now when I expand that out to see what I would get, my first two terms come out nice enough, but there's a number that's going to come along for the ride if I'm going to have this arrangement, and that number is this whole part squared. Now you can see why I've just left this as a fraction, because it's much easier to square that way. It's a negative number. When I square a negative, I'll get a positive. So I'm going to get 49 over 4, and I've simply just squared the 7 and squared the 2. So keep this as an improper fraction because it makes it much easier to square. All right, now I've gone and added 49 quarters that wasn't in my question, so I'm going to take that off again, so it's almost like it was never there. But I did have a 2. Now carefully compare your lines. Are these two the same? Yep, they've just got the 49 quarters added and taken away again. Are these two the same? No, these three terms are taken care of here, but these last two terms are the ones that I need to tidy up. So here what I've really got is, what's that, minus 12 and a quarter, and then I'm adding 2, so I've actually got minus 10 and a quarter, which I can write in a variety of different ways. Now the last examples were all just algebraic expressions. They didn't equal anything, and I was just fiddling with them to make them look different. This one's a different arrangement because it's actually an equation, and it equals something. So you can use the exact same method that we just used on this side and keep letting it be equal to 0 on the other side if you like. But a few other strategies can make our life a bit easier here. We can actually start, if we want, by getting rid of that 7 by adding 7 to both sides. Now we've just got the first two terms that if I leave a line, I'm looking for an arrangement that's going to be something like this. Now I can reason that to find out what this number is, I need to just halve my minus 2, and I'll get minus 1. And now when I expand this out, I can see I'm going to get x squared minus 2x, but whether I like it or not, I'm going to get the squaring of minus 1, I'm going to get plus 1 as well. Now, what have I done here between this part and this part? Well, I've added 1 to the left-hand side of the equation. So to make up for it, really I need to add 1 to the right-hand side as well. Now just check if those are balanced. All that's happened between here and here is I've added 1. And now here I've just tidied this side up and made it a perfect square. And now I need to just tidy up this side. Solving it from there on in now, you can actually figure out what x is. Easiest way to do it, take the square root of both sides. And remember you'll need plus and minus square root of 8. Square root of 8 is 2 root 2. Now to get the x by itself, I need to just add 1 to both sides. So I can add the 1 first and write it like this. Or I could tack on a plus 1 at the end. Same thing either way. A slightly harder example because this one's going to have fractions in it. I'm going to start the same way I did last time by adding this constant to both sides just to sort of get it out of the way. Now I can focus on these two and think about what they're going to need to make this arrangement happen. Well, I'm going to have to halve the minus 3, aren't I? So I've got minus 3 halves. Now when I expand that, I get x squared minus 3x. That's good. But I also get positive 9 quarters. Now, I've gone and added 9 quarters to this side, but it wasn't in the previous line, so I have to do the same to the other side. Now, these are taken care of here, and here I've just got to tidy up. So I'm going to keep this in quarters, and there's a reason that you'll see in a minute. When I take the square root, if I take the square root of quarters, I'm going to get halves there, so that's going to be nice and easy. So 5 is 20 quarters, so altogether I've got 29 quarters on that side. Now if I take the square root of both sides, I've got the positive and the negative of the square root of 29 quarters. And that's exactly the same as if I take the square root of the 29 over the square root of the 4 separately, isn't it? Square root of 4 is 2. So I might just tidy that up while I'm there and actually just write that as a 2. Now you could do that on the next line. I'm just saving space because I'm running out of board here. Last step to get the x by itself, let's add 3 halves to each side. And we're going to have 3 halves plus or minus our root 29 over 2. Now both of these are going to have common denominators, and that will happen every time. Because we've squared the 2 to get 4 in the first place, when we take the square root of 4, we're going to have 2's again. So we can tidy this up and actually put them both over the one denominator there so that it looks a little bit neater. Now, if you're wondering why I like to leave a line at this step here, it's quite simple. To work out what goes here, this 9 quarters, it's a 2-step process. You need to halve this number, but then you need to square it. So if you're doing 2 things at once, saying, all right, I've got to halve that and then I've got to square it, that's 2 steps that you've got to do potentially in your head or on your calculator. Then when you write down that 9 quarters, and because you've halved the -3 and you've squared it, when you get down to this line, people sometimes then get confused and accidentally put the 9 quarters in here. So I figure if I've got to halve something and then square it, when I've halved it, I may as well write it down where that needs to go. Then when I'm looking at it, it's much easier to square it because I can already see what number I've got to square. So that's why I like to leave that line and then just look at the lines and juggle them and check that everything's evening up and working out. Now the only way that this can really get any harder is if you have a coefficient in front of the x squared. So let's do one of those. Let's say we have something like this. All right, first step, let's get rid of that 7 by adding 7 to each side. Then let's divide everything by 2. Why? Because I want the x squared just to be x squared on its own. So if I halve that, I've got to halve that, and I've also got to halve that. And I'm just going to leave it like that for now. All right, now I can deal with this and go leave a line. Let's go down to the next line. We're looking for something that looks something like this. I know I need to halve my -3. And then when I expand that back out, I'm going to get my x squared minus 3x well enough, but I'm also going to get that positive 9 quarters, whether I want it or not. So here, if I've added 9 quarters to the left side, I need to add 9 quarters to the right. And I'll tend to just write down what I'm doing here, and then I can reach for my calculator or I can figure it out to work out what I'm doing on the next line when I tidy up, because this line's already written on the left. So really here, I can now see clearly what I'm doing, and I don't have to do too much in my head. I'm going to leave this in quarters and say I've got 14 plus 9. I've got 23 quarters. All right, now we'll take the square root of both sides. We need the positive and the negative version of this. And once again, I can see that the square root of 4 is just 2. So rather than write it down that way, I'm going to make it like this. And now I'm going to add 3 halves to each side. So I've got 3 halves plus or minus 23, root 23 on 2. And notice that the same thing's happened here. I've got my halves. So I can actually make the entire thing, it's a little bit messy, sorry about that, over 2. And I'm done. So this one, if you've got a coefficient out the front, start by dividing the entire equation, every term in it, by that number, and then proceed as we did before.